Hey guys, it's Miss Reynolds. Welcome back to the math class. So today we're going to be talking about fractions. I know that can sound a little anxiety inducing because fractions are hard to deal with sometimes, but usually that's because we're using what's known as the standard algorithm to solve them. The standard algorithm can be kind of complicated, so we're going to be looking at non-standard algorithm ways to solve fraction problems. Okay, so here in our summary we can see that we'll be adding fractions using visuals, we'll be subtracting fractions using equal addends, and then we'll be multiplying fractions using our partial products. We will also be solving fractions using the standard algorithm as we review student work. We're going to see where these students may have gone wrong in their process of trying to solve the equation. We're going to correct it, and then we're going to solve. Okay, from there, we will be using the non-standard algorithms. So let's jump in. Here is our addition. So our addition problem states 5 over 10 plus 3 over 4, and this student said that it was going to be 5 over 10 plus 9 over 10. The first thing I noticed is that this student wanted to get the two denominators that were the same, and I will say that's really good thinking. We need to always realize that when we're trying to combine fractions, the denominators need to be the same. Okay, but the way that this student went about making them the same is not quite right. Okay, so here the student added 6 to make the denominator also 10, and they added 6 to the top to make this 9. Now this part made me smile because even though adding 6 is not quite the way that we're making this fraction equivalent to the other one, I really loved the way that they knew that if you add something to the bottom, to the denominator, you need to add it to the numerator as well, because it's going to keep the fraction balanced. Okay, so again, I really like the thought process here. I see your thinking, but we're not quite there yet. We're going to help you get through it, okay? So here, like I mentioned, this student was trying to find the common denominator by adding instead of multiplying. It's multiplying that we need to do in order to get the common denominators. Okay, so we're going to find the common denominators by multiplying 10 times 2 and then 4 times 5 to get 20 for both of the denominators. Now you might be asking, why are we using 20 for the common denominator? We didn't talk about this. Well, if you think about it, it makes perfect sense. So we're looking for a common denominator that both 10 and 4 can fit into. Okay, but it has to be the smallest possible number. So we know that 10 goes up by increments of 10, so 10, 20, 30, and so on. And then 4, we have to see which one of those numbers 4 fits into. So if we're counting by 4s, 4, 8, 12, 16, 20, 20. So we have 10, 20, and then we have 20 for 4s on the other side. That is the smallest number. 20 is the smallest number that 10 and 4 can fit into. Okay, so that's why we're using 20 for our common denominator. So with that said, we would multiply 10 times 2, that would give us 20. And as the student had pointed out to us, we need to keep this equation balanced. In order to do so, we're going to take this 2 and multiply the numerator by 2 as well. That's going to give us 5 times 2 is 10, 10 times 2 is 20. That's represented here in this fraction. So same thing for the other side. We have 3/4, and we have to make the 4 into a 20. So 4 times 5 equals 20. We know that we need to keep the equation balanced, so we're going to multiply the numerator by 5 as well. 3 times 5 is 15. Now if we look at this, it's a lot easier to be able to add 10 over 20 plus 15 over 20 gives us 25 over 20. Notice now that this is an improper fraction. 20 goes into 5 one time. It gives us a remainder of 5 over 20, and both 5 and 20 can be divided by 5 to give us 1/4. So the answer here is 1 and 1/4. Okay, so that's the standard algorithm. But we're going to go ahead and look at this same problem using fractions with visuals. Again, we have 5 over 10, we have 3 over 4, and we represented them here. So this is 5 over 10, and this is 3 over 4. when we make these little pie charts, we can easily see that 5 over 10 is equivalent to 1/2, and it's also equivalent to 2 over 4. But up here, it was a lot harder to see that. If we would have seen that it was 2 over 4, it would have been a lot easier for us to combine these numbers in the first place, and we wouldn't have had to multiply and get common denominators and do all that stuff. It would be a lot easier for us to visually see it, okay? But down here, since we do have the visuals, it is so much easier for us to dissect this problem and see what it's asking of us. So now that we know that 5/10 is equivalent to 1/2 and also 2 over 4, we can decide which one we're going to use to represent it. So we're going to choose 2 over 4 to represent our 5/10 because they're equivalent fractions. And the reason for that also, the reason why we're choosing 2/4 is because our other fraction is already in fourths. So that would make it so much easier. This is using the same amount of pieces is like getting a common denominator in a sense. Okay, so there's fourths in this one, there's fourths in this one. Now we can count how many fourths we have. We have 1, 2, 3, 4, 5 fourths. So writing that out, 5 over 4, we can notice that this is an improper fraction. 4 goes into 5 one time. That gives us a remainder of 1 over 4. So without any sort of messy multiplication or anything crazy like that, we got the same answer as above, and this was a much simpler way to do it, okay? So using visuals is a great way to help you understand and see fractions, especially for someone who's a visual learner like myself. This is such an amazing tool to use, okay? So moving on, we're going to do subtraction now. So this is the student work. Let's look at the equation first. So the equation here says 5 2/3 minus 3 8/10. So the first thing that I notice is that the student wanted to get common denominators. I love that. I love that we know that in order to manipulate fractions amongst each other, they need to be in equal parts in terms of denominator. I love that. All right, so that's good. But here's the issue. Let me grab my pen and we're going to figure this out. So notice that 20 minus 24 would give us a negative number. And that's not quite right. In order to avoid negatives, and messing up our whole equation potentially, this is not quite the way to do this. In order for us to be able to solve this, we're actually going to need to convert to improper fractions. Part of the standard algorithm is converting to improper fractions. There's a lot of multiplying involved. It can get messy sometimes, okay? So I actually took the liberty of already doing the work for this. There we go. Let me go ahead and scroll back over just a little bit. Wonderful. Okay, so let's look at this. We need to convert our proper fractions into improper fractions. That means 5 times 3 is 15, plus 2 is 17. We keep the denominator from the original equation. Now for the next one, 3 times 10 is 30, plus 8 is 38. Again, we keep the denominator from the original equation. So moving on over, we need to now find the common denominators. Okay, so here again, we'll see that 10, 20, 30, and then counting by threes all the way up to 30, that's the smallest number. 30 is the smallest number that 10 and 3 can both fit into. Okay? So in order for us to get the same denominators, we're going to need to multiply the denominators by the number that would make them 30, which would be 10 times 3 on this side. And as we know, we need to keep the equation balanced, so we multiply the 10 by the 17 on top. So if we were to do that, it would be 170 over 30, which is represented down here. We would need to do the same over here, so 10 times 3 is 30. And we're going to use that same 3 to multiply the numerator so we can keep the whole equation equivalent. 38 times 3 is 114. Okay, so 114 over 30 is represented down here. Now we need to do some subtraction. We have 170 minus 114. If we do the math for that, that gives us 56. And of course, we're going to put the 56 back over 30 because that was our common denominator. Looking at 56 over 30, we can also notice that this is an improper fraction. So we need to convert back to a proper fraction, and then we're going to reduce. So 30 goes into 56 one time, with a remainder of 26 over 30. 26 and 30 can both be divided by 2, which gives us the total answer of 1 and 13 over 15. So again, in the standard way to solve fractions, there's a lot of converting and there's a lot of multiplication. So it can be a little, there can be many steps, and it can be a little frustrating, especially if you make little mistakes. It can ruin everything. So we're going to look at a second way to do this subtraction problem, and this is called equal addends. So basically, with equal addends, our priority here is to make this second fraction as nice as possible. So you might ask, what does it mean to make a fraction as nice as possible? Well, the nicest number that you could deal with is a whole number, right? I'd rather deal with a whole number if I could. So in order to make 3 and 8/10 a whole number, we have to add 2/10, because 8/10 plus 2/10 equals 1 whole, plus the 3 is going to give us 4. So that'll give us a 4 on the bottom, okay? So as we know, though, we need to keep the equation balanced, equal, okay? So if we're going to add 2/10 to the bottom fraction, we also need to add 2/10 to the top fraction. That's why over here, we're going to see 2/3 plus 2/10. That's the portion that we're going to be focusing on. We're going to hold on to the 5 minus 4. We're going to put it aside for the moment, and we're just going to focus on this addition problem now, okay? So 2 over 3 plus 2 over 10, we need to find a common denominator. As we decided prior, the smallest number that 3 and 10 can both fit into is 30. So in order to make 3 into 30, we multiply it by 10. In order to keep this fraction equivalent, we multiply the numerator by 10 as well. That's going to give us 20 over 30. Now, for the second part of the equation, we have to do the same thing. So 10 needs to equal 30. In order to do that, we multiply it by 3. So 10 times 3 equals 30. That 3 also needs to be multiplied to the top number, the numerator, to keep the equation balanced. So 2 times 3 is 6. This gives us 20 over 30 plus 6 over 30. Now we can easily add that. It's 26 over 30. We added it. Now we can simplify. So again, we know that if we divide 26 by 2, it'll give us 13. 30 divided by 2 is 15. So this isn't our answer, though. This is part of our answer. Now we have to bring back the 5 and the 4. So 5 and 13/15 minus 4 would give us 1 and 13/15. 5 minus 4 equals 1. 13/15 minus nothing just brings it right down into the answer. So 1 and 13/15 is the answer. So the benefits of using our equal addends non-standard algorithm is that there's no need to convert with messy fractions, okay? And then it also allows us to work with nicer numbers. Let's take a look. This was our original equation. And then once we were done doing our equal addends, this is our equation that we ended up using to solve our ultimate equation with, okay? We got the same answer from the standard algorithm to the non-standard algorithm, but the non-standard algorithm was a little bit easier, in my opinion, to deal with, okay? So moving on, we're going to do some multiplication. Again, this is the student's work. The first thing that I noticed here was that this student was trying to just multiply straight across. And it seems like it would be the most obvious way to do it, but it's not quite right. So he did 2 times 4 gave us 8, 3 times 3 equals 9, and then 4 times 5 equals 20. So his answer was 8 9/20. Now, that's not quite right. In order to consider all parts of this multiplication problem, we need to make all the pieces equivalent, okay? That includes the whole numbers. So in order to use the standard algorithm to solve this problem, we would need to convert it to improper fractions first, okay? So that means that converting to improper fractions, we would do 2 times 4, which equals 8, plus 3 equals 11. We take that denominator number, which is 4, and we hold on to that, okay? And then so for this one, it would be 4 times 5 equals 20, plus 3 is 23. Again, we hold on to the original denominator. And now between these two fractions, we need to find what the common denominator is. And I will give props to the student because this is the smallest denominator that 4 and 5 can both fit into. 20 is the smallest denominator that 4 and 5 can both fit into. So that was awesome. Good job on that. So now we have to decide how we're going to do that. 4 times 5 equals 20, of course, and that same 5 is going to multiply our numerator so we can keep this whole equation balanced. So 5 times 11 equals 55, 5 times 4 equals 20, that's our fraction here. Now we have 23 times 4 and 5 times 4. 5 times 4 is 20, so that gives us our 20 on the bottom over here. 23 times 4 gives us 92, which is represented here. So this is 55 over 20 times 92 over 20. Now, honestly, I used my calculator for this part because multiplying fractions can be hard, and then multiplying like huge fractions is even worse. Part of the standard algorithm is the fact that you have to do a lot of converting and a lot of multiplication, and that in itself is frustrating for somebody who already slightly struggles with it. So I used a tool, my calculator, to help me solve it. So the answer that we got from our calculator says 12 and 13/20. Okay? But now we're going to look at a way to solve this same problem using our partial products algorithm. So again, we have 2 3/4 plus 4 3/5. The first thing we need to do for partial products is create this square, put a little cross through it. It gives us 4 sections. And from there, we just have to put each of our fractions along the sides of our square. So we have 2 3/4 here, then 4 3/5 here. In each of the corresponding squares, we're going to multiply the numbers. So for example, 2 and 4 would meet here. It would give us 8. 3/4 times 4 is 12/4. 2 3/5 meets here. It's 6/5. And then 3/4 and 3/5 meets right here. It's 9/20. Let me go ahead and there we go. All right, so on this next part, now we just need to write out the products that we identified, and then we need to identify the whole numbers. So we have the 8. Let me go up a little bit. There we go. We have the 8 from the first square. We have 12 over 4, which actually also is 3. 3 wholes, okay? And then 6 over 5 is also an improper fraction. 5 goes into 6 one time. It gives us 1 whole, and then it leaves us with the fraction 1/5. So identifying our whole numbers, we have 8, 3, and 1, and then we have the fractions 1/5 plus 9/20. We're going to hold on to these 12 whole units and kind of just push them aside for the moment because we need to focus on the 1/5 plus 9/20. As we've been saying this whole time, we need to find a common denominator between 1/5 and 9/20. In order to do that, we already established that it needs to be the smallest number that both numbers can fit into. Considering 20 is already 20, it would be 5 that can also fit into 20. We would need to multiply that by 4. We do nothing to 9 over 20, but we need to multiply some numbers to get this one here to match this one here. So in order to do that, it's going to be 5 times 4 gives us 20, and then that same 4 needs to be multiplied on the numerator to keep the whole entire fraction equivalent, and that's going to give us 4 over 20 plus 9 over 20. Now if we add that across, it gives us 13 over 20. But again, we're not done. We had 12 whole units to bring down. So we're going to write the whole answer, which is 12 and 13 over 20. So as a visual learner, personally for me, I found this way to be a little longer, but a lot more insightful as to what's going on with my numbers. Okay. It does take a little bit longer maybe, but it gives you a clear visual representation of every single part. And then ultimately you'll be able to get the answer by yourself without having to do some crazy big multiplication with fractions. Okay, we got that same answer. So just to kind of wrap everything up, looking back at what we did today, we were adding fractions using our visuals. We were subtracting our fractions using our equal addends, and then we were multiplying fractions using our partial products algorithm. All of these are ways that can be used to solve fractions instead of the standard algorithm way, which usually is a lot more complicated, and there's a lot more converting and there's a lot more multiplication. So using non-standard algorithms is a great way to be able to approach fractions, especially when they may be a little harder than doing other types of math problems. I hope you guys found this helpful, and I'll see you next time in our math class. Have a good one. Bye.